Here's how my code works for the thermostats and timers. This is the Arduino IDE. The slashes mean a comment, so I put notes in to remember what I did and for anyone else to understand it. Includes are ways to bring in other code. You want to specify what you want, and it is all based on the examples. Let me show you how the examples work. For example, if we want to see a Pololu A-star music example, we click on File, Examples, then scroll down to A-star, and then pick Buzzer Basics. Here's the code to play a custom song. I'll show you a similar code in my program. The examples make it very easy. We need the includes for the one-wire sensor and for the I2C clock. Interesting, the one-wire system needs 3 wires and the 2-wire system uses 4. That's because you need power and ground. Here are the addresses for the sensors. Here are the includes for the Pololu libraries. The LCD buzzer are easy to define. For the alarms, we use a series of notes, just like the example code I showed you. These variables are used for the thermostats to determine when to turn the heater on and when to play the alarms. We define all the pins that we use. Here are the variables to read the clock. To make it easy to set the timers to partial hours, we need to create these floating point variables for decimal hours and minutes. The setup runs only once and is used to set up all our variables, start the sensors and clocks. Lots of this just came from the sample code provided with the library. Nora helped me set up the variables to talk to our safety system. Here is the loop. It just keeps running over and over. After the heartbeat check, we check for pressing the demo button. Next, we read the temperature sensors and display them on the LCD. Here we read the real-time clock and do the calculations for the decimal hours and minutes. Remember what I was saying. This makes it easy to use partial hours, like 9:30 would be 9.5 in decimal hours. For the demo, we shut everything off after the 60-second demo. Digital write is an output. Now we set the relay states. Note that low turns the relay on and high turns it off. For the light, we want it on before and after the demo, so the logic is a little different here. Here's the thermostat logic to set the relay based on our defined temperatures. Finally, check for the alarm temperatures. That's pretty much it. It was actually a lot more work than it looks.